So now we know where it is. Now, there's something else I want to do. Let's see something. Okay, so now we get to the outputs. And I'm on line 289. You can get to here a couple of ways. You can use that slash and look for something like ICO to get down here. Or you can just do what I did, which is just hit the down cursor till you get here. But anyway you look at it, we're now in, the outputs. And what we're going to do is we're going to save the output of this model for initial conditions and subsequent runs. Okay. And this is very common. Remember I said, just for example, like an 11,000 cell model, you have to name the initial conditions in every single cell for every state variable. Nobody can do that. It's humanly impossible. But what you can do is save, at the very end of a model run, you can save all 11,000 cells for all those state variables. So what we're going to do is we're going to save the output for use in a subsequent model run. Right now it's set for something I did previously. It says output 2. I think this works. Let's try this. If I put the cursor on the 2 and I type X, that takes out that symbol, right? Let's try it. Look at that. That deleted the 2. So now we're going to create something called WQM initial conditions output.opt. Given that I hardly work on these machines anymore, I'm trying to remember, how did I, at one time I could have done anything in VI, and now it's like, oh my God, oh my God, oh my God. But anyway, okay. So I think we've done all we need to do. If we haven't, we'll get an error and we'll do something else. Everybody's got this? Now, what we got to do, we got to save our changes. Hit the Shift key with your left hand, the colon with your right hand. And you'll see a colon comes up there, and you want to type WQ, write and quit. So we've written the new control file, and we've gotten out of it. Now, just for curiosity, okay, so this over here, this one I'm going around right now, at least on, for those of us who are working up on Cloudfish or whatever, that's an executable water quality model. It's been compiled. It's been compiled on this machine, so Lord willing, it's going to run for us with no trouble. I just want to see for curiosity, this is submitting that water quality model to the batch queue. This is the command that Richard typed in earlier, and we found out that we all just got in the queue and then had nothing else to do for the morning. But I'm curious to see if this is going to work or if John has got this up to date. So for curiosity, let's submit it to the batch queue. It appears to be running. I hope it's running.
Yeah, it's running.
Okay. Your codes, you may have, it may be spitting out numbers. I'm not sure if it's spitting out numbers or not. That was relic. Putting out that numbers was a relic of some debugging that I did. So the fact that it didn't come back and say you got a problem means we don't have a problem. All right? I hope. We'll sit here a couple of minutes, and then if it doesn't finish, the hell with it, we'll do it in the foreground. But that's how you submit a run to the batch queue.
Yeah, and it shows me as being in the queue.
Excuse me?
I'm in the queue.
Okay. But you're not running, you mean?
Not running.
Okay. Richard, how are we doing?
Most likely on, I think four nodes available. So simultaneously 4 jobs are running, others are waiting.
Oh, here we go. Mine's going.
Okay.
There is who is the student too?
Mine is finished, so hopefully somebody else runs now. We will, in the future, or now you know how to submit to a batch queue, and you've learned that very often in high-performance computing, you spend more time in the queue waiting for your job to run than it actually takes for the job to run. So hopefully your job will run.
You do? Yeah.
How's everybody doing?
This is cute.
Yeah.
He was able to do it.
Oh, that's what he changed. Is that out too? Yes.
No, I got an error.
Yeah. Yeah, I was just checking. Yeah.
Yes.
It's finished.
Mine's finished.
My feelings that's good.
Yeah. That's correct. Yep. No, that was the last one.
That's okay. I don't know it works.
Something, let's go back.
Yeah, you need to file maybe to pop a 2 off the .opt.2.
Yeah.
Carl,
Yeah.
what were the 2 changes you made in the control file? There was the uniform, and there was another file you changed, took the 2 off the.
Okay, I specified uniform initial conditions. I had to say where those conditions were found, so I changed that file name.
Right.
And a relic of the previous runs I made was where I put the conditions for the next one, so I gave that a new name. So there were 3 changes altogether.
And the ICI file was output/WQ
Oh, it's inputs.
inputs.
When we get settled there, maybe run that one in the foreground so we can finish that and move along.
This is ICI.
Oh, that. Oh, okay. I think
Carl, it makes 2 binary and 2 ASCII files.
I don't know.
And outputs, it tells what those are.
Yeah, the only, what you've made, Dominic, you've made, for example, the file, as Richard mentioned, that we usually use is called an APL. And that's a big binary file, and you've created it. We're not going to work with it.
I'm just curious what they are.
And the binary, also the initial conditions that we output are in binary.
Yeah, this is good. Yeah,
WQ.
So the output processing files work from the binary, is that how it works usually? When you're processing? When you're processing, you go from the binary file?
Excuse me?
APL file is what you normally process?
Yeah,
And the snapshot is just to have a look at whether it ran sensibly?
yeah, exactly.
Okay, got it.
Sometimes too, if the model run bombs, you can inspect the snapshot file and see what was going on before it went to hell.
Yeah, got it. Good.
Cassie, did you got it?
No, we got some.
We're working on it, yeah.
What kind of error do you get?
I have some error also. I have error also.
Oh, you have that?
Something, recall in that control file that those inputs like uniform and binary, that's a formatted file. They have to be right justified. And the end of that has to be right under the end of the ICIC. If it isn't, you got a problem. Also, they have to be uppercase. So if you use lowercase, you got a problem.
Also has a format, like if you're shifting, is that formatted?
What's that? Yeah.
So like, I'm gonna shift the one column, everything.
You gotta write justify everything.
The M of uniform should be under the last C of ICIC.
We have the wrong file name.
That'll do it.
You know, when I had said earlier, when I did this in March, I did it on my PC, and which was very easy. And then we got some comments from some of the audience, well, why didn't we do that up in the cloud where we run the real model? So we decided for this class, we're going to do it on the supercomputer, and we see how much fun it is to work with supercomputers. How's everybody doing?
Still error.
Most likely, you are right. I think the control file.
Oh, it should be right aligned.
Meters, all yards, oops.
I mentioned Monday that the inputs here are kind of clunky. They're really outmoded. Your run shouldn't fail because you were one space off. But life being what it is, here we are. So is that run completed or still going? The basics of reading a control file are almost 30 years old. So if we were doing it again, I don't think I'd format those inputs. You know what I mean? But like I said, what is. Okay, so let's type ls list minus lotr. What that is going to do, it's going to give us a list of our files, and it's going to give us lengthy information, but the thing we really care about is down here. On July 24th at 14:48, we created a snapshot file. So if you see that, you know your run ran successfully. Okay. Now what we're going to, okay, so that's step one. So we submitted the job. Now step two is to extract the information that we want. And we're going to do quite a bit of this. What do we want to do? We want to do salt, temperature, DO, and ammonium. So all right, we're going to do this in the foreground. So we're not going to submit this to the batch. We're going to type /, and we're going to type read _ snp _ file. So that's our processor that's going to take the big stuff, the big model output, and convert it into something smaller that we can work with. For the sake of the class, we're going to read that ASCII snapshot file. Normally we read the APL file. We're not going to worry about that. So the /, anyway, this is going to run this program in the foreground. We not submit it to a batch queue, and we hope it doesn't blow up this supercomputer, right? Okay, so we've got a list of variables. What variable? I'm going to type 1. Now, recall you have that file that's something like key to snapshot file, or it was distributed. So if you look on that, you'll find that number 1 is temperature, but since we're let's just take my word for it, number 1 is temperature, okay? So we're going to get the temperature output from the water quality model. What sediment variable? Type in 4. Variable 4 is the G1 carbon. And if we remember from the diagenesis lectures yesterday, G1 is the labile carbon. And enter.
Multiple, if you wanted multiple variables, could you do like one?
No.
Like,
I should have done that, but for now, too late. So what we're going to have to do is we want multiple variables, but we're going to have to, we're just going to have to run it repeatedly.
Okay.
But for the sake of getting it done quickly and getting it into the classroom, this is the way it works. Once again, I'll ls. Okay, so everybody's there? And if you look now, if you do that ls minus lotr again, you'll see that now you've got two brandy new read snap file.outputs. Now again, clunky, and if I had to do it again, I wouldn't do it this way. Every time we run the read snap file, it's going to write read snap file, WQ output, and sed output. So if we run it repeatedly, we're going to keep writing over our stuff. We don't want to do that. So as Richard showed us earlier, we're going to rename those or move those. So let's move WQ output. Let's move that into something we're going to call temperature round 1, because this is round 1 of the model. Go ahead, Dom.
What were the two variable numbers? 1 and,
1 and 4.
thank you.
A funny thing about Unix, and not a good thing about Unix at all, this is going to write over my previous, you'll see there's already a file there called temp_round1 that I created, I think there is anyway, yeah, that I created on July 10th. It's not going to ask me, do you really want to write over that file? It's going to do it, you know, so keep in mind that, you know, if you don't really know it, well, anyway, okay, easy enough.